Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x plus 2 times x plus 2, or you can write x plus 2 squared. Okay. For the math knowledge question, we are trying to raise $1,250, and we can either do a candy bar or the photo booth. And down here it says for the photo booth. So after paying a startup fee of $25, they sell them for $3 and they cost $1 to print. So how many prints must be sold to cover the startup fee? So every one that they sell, they're going to make $2 because there's a difference between $1 and $3. That's the difference between those. And we have $25 to have to cover. So $2 times what equals $25? Well, that's going to be 12 and a half. So they have to sell at least 13. You can't sell half of a print. You have to sell at least 13 just to cover the startup fee. Okay, so now we're going to look at lesson 44. We're going to be applying similarity. So hopefully you'll understand how to apply similarity after this lesson. So looking at this example, the pentagons are similar. We want to find the values of x and y to the nearest hundredth. So since we have similar figures, that means that we can set up ratios. And we can set them equal to each other to make a proportion. So x to 12 equals 14 to 18 equals 13 to y. And then from there, I'm going to reduce this 14 over 18. If you divide them by 2, that'll give you 7 over 9. And then you can cross multiply, and you'll have 9x equals 7 times 12, which is 84. And it says round to the nearest hundredth, so we're not going to leave it as a fraction. So 84 divided by 9 is 9.33. And then for y, if you cross multiply, you'll have 7y equals 91. No, sorry, 117. And then if you divide by 9, you'll get 13. No, divide by 7, sorry. You'll get 16.71 for your y value. Okay, so that would be how you use your ratios to solve for your missing side links. Looking at this next one, it tells us that these two hexagons are regular and similar, and the similarity ratio of one to the other is 5 to 4, and we want to find the values of x and y. So let's start off by finding y here. We know that this side is congruent to this side because it's a regular hexagon. So that means that 2y plus 9 has to equal 45. And so if you subtract, 2y would equal 36. And so y would equal 18. For x, they tell you the similarity ratio of this one to that one is 5 to 4. So you're going to say 5 over 4 equals 45 over x squared plus 11. And then if you cross multiply, I'm going to come down here. We're going to have 5x squared plus 55 equals 4 times 45, which is 180. And then if you subtract 55, 5x squared is going to equal 125. And then divide by 5, x squared would equal 25. And then if you take the square root, x would equal plus or minus 5. Okay, so that's how that one would work. Now we're supposed to find the ratio of the perimeter. So for this one, the whole perimeter is going to be 45 times 6, which is 270. And the perimeter over here, well, 5 squared is 25 plus 11. That's 36. And if you multiply 36 times 6, you get 216. And it wants to know the ratio of this perimeter to this one. So 270 over 216 reduces to 5 over 4. And so that would be the ratio of your perimeters. What do you notice about that number? It is also the similarity ratio, or the scale factor. Your ratio of your sides is always going to be the same as the ratio of the perimeter, which is what this theorem 44.1 says. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of the corresponding sides. So let's look here. We want to prove that the ratio of the perimeters is 1 to 5 if the ratio of the corresponding sides is also 1 to 5. So the first thing that you're going to do is make your 2-column proof. And then from there, your first thing is going to be your given. And so they tell you, given that the triangles are similar, so that's going to be your given statement. From there, we can say, if we draw the two triangles, we can set up side AB over side DE, because those are corresponding, is going to equal side BC over EF, because those are corresponding. And it's also going to equal AC over DF. And all of those are going to equal 1 to 5. And that's part of the given, because it says the corresponding sides are in a ratio of 1 to 5. So if we cross multiply on each of these with the 1/5, that means that DE would equal 5 times AB. EF would equal 5 times BC. And DF would also equal 5 times AC. And that's just from cross multiplying. Okay, from there, the perimeter of triangle DEF is equal to your 3 side lengths, DE plus EF plus DF. And that's just definition of perimeter. And then the same thing for perimeter of the other triangle. So that would also be definition of perimeter. And then if we substitute the perimeter of triangle DEF would be 5 times each of these, AB, BC, and AC. And that's from substitution. Property of equality. And then if you look at this one and these last two, this perimeter and this perimeter, the perimeter of triangle DEF equals 5 times the perimeter of triangle ABC. And that's using substitution again. And so that shows you that the perimeters are in a ratio of 1 to 5. So that's how you could go through that one. You didn't need any numbers other than the 1 and the 5. You didn't have to give numbers for your side lengths. You just needed to tell how that the ratios end up making the perimeter also the same ratio. So we're going to look at this next example. So for this one, they tell us that we have two similar polygons with ratios of 7 to 3 for the sides. And if the perimeter of EFGH is 35, what is the perimeter of the other one? So the first one they give us is EFGH. So that means that it's going to have to go on top. And then we're going to be looking for the perimeter of the other one. And so we know the perimeter ratio has to be the same as the ratio of the sides. So if you cross multiply, you'll get 7P equals 105. And then if you divide by 7, you'll get 15 inches for the perimeter. And that's all you have to do on those. Just set up ratios and then solve them. Looking at this next example, we have 700 meters to run for a race, and we run in the shape of a hexagon. The side lengths of the park measures 2 centimeters with a scale of 1 centimeter to 100 meters. How many times does she need to jog the perimeter to complete her daily training? So 1 centimeter is 100 meters. So that means that if it's 2 centimeters on a map, each side length is going to be 200 meters. And the perimeter is going to be 6 times 200, which is 1200. And so how many times do we have to go around to get to 6,000? Well, 6,000 divided by 1200 is 5 laps. So that's how many laps she would need to make to get her training in. Okay, so now we're going to look at some practice problems. So y'all try these two by yourself, and then once you're finished, unpause the video and I'll go over them. So we're going to have x over 21, 11 over 33, and y over 27. And this 11 over 33 reduces to 1/3. So 3x equals 21. So that means that x equals 7. And then for y, 3y equals 27. So y would equal 9. Okay, looking at this next one, they give us triangles and we want to find the values of x and y and the ratio of the perimeters. So I'm going to draw them out. And fill in the side lengths that they give you. Okay, so that's the information they tell you. And then from here, we can set up ratios. One ratio would be 5 to 15, which is 1 over 3. And then x squared minus 7 over 6. and then y plus 4 over 12. So if you cross multiply, you'll get 3x squared minus 21 equals 6. So then 3x squared would equal 27, and x squared would equal 9. So x would be plus or minus 3. And then on this other one, 3y plus 12 equals 12. 3y would equal 0, so y would be 0. And then it wants you to find the ratio of the perimeters of your two triangles. Well, the ratio of the perimeters is just going to be the ratio of the two sides. So that was 5 to 15, which reduced to 1 to 3. So the ratio of your sides, of your perimeters, is just going to be 1 to 3. So that would be your answer there. Okay, looking at these. They tell us information, and they want you to find the perimeter of the figures. So y'all pause the video and try these, and then we will go over them. So we know the corresponding sides are in a ratio of 3 to 5, and EFG is the second one they give us. So the 45 has to go on the bottom, and then we're looking for the perimeter of the first one. So then you multiply, you get 5p equals 135. And so if you divide by 5, p will equal 27 inches. Okay, for this last one, they tell us the perimeter of 1 is 32, and the ratio is 2 to 9. So we're looking for the perimeter of the second one they give us. So if you cross multiply, 2p equals 288. And then if you divide by 2, you're going to get 144 centimeters. So that would be your perimeter for that figure. Okay, we're going to look at one more practice problem. So y'all try this one by yourself, and then unpause the video and I'll go over it. So we have Jana and her door, and we have Jacob and his door. Jacob is 3 feet tall, and Jana is 4 feet tall. Her door is going to be 5 feet tall by 2 feet wide. And we want to know the length and the width of his door. So our similarity ratio is 4 to 3. And then we're going to do 5 over L and 2 over W. So if you cross multiply, you get 4L equals 15, and if you divide, your length is going to be 3.75 feet. And then if you do the same thing for your W, 4W equals 6. So W will equal 1.5 feet. It asks for the height, how tall, so that's that one. And we needed to find this so that we can find the perimeter. So the perimeter is going to be 2 times the length plus the width. So if you multiply, your perimeter should be 10.5 feet. So that would be your answer for that one. Okay, so now we're going to look at the challenge question. So let's see if y'all can go through this one by yourself, and then I'll go over it. So it tells us the concept of similarity also applies to closed figures that are not polygons. Two similar equilateral triangles each have a semicircle appended to one side so that the side forms a diameter of the semicircle. Prove that the ratio of the perimeters is equal to the ratio of the corresponding sides. So this is what our figure is going to look like, basically. Kind of like an ice cream cone. So we're going to let S equal the side of the triangle. And then we're going to have a bigger one. And we're going to say S times some number n. So the perimeter for the first triangle with its hemisphere here would be 2F and then plus 1/2 pi times S. This is semicircle, so the circumference formula you can do is pi times your diameter, because this length is your diameter, which is S, and then we're doing half of that. And then the perimeter of the second one would be 2 times Sn plus 1/2 pi times Sn, because again, Sn is your diameter. And then we need to do the ratio of the perimeters. So we'll do 2S plus 1/2 pi S over 2Sn plus 1/2 pi Sn. So up here, we can factor out an S, and we're left with 2 plus 1/2 pi. And then down here, we can factor out an Sn. And we're left with 2 plus 1/2 pi. And so those cancel, and they leave us with just S over Sn. And that's the ratio of the sides, S to Sn. So that would be how you would prove what they ask you to prove. So your homework is 1 through 30, so make sure you do those tonight so we can go over any questions you have tomorrow.